Okay, great. So you've mastered the art of graphing using slope-intercept form. What I'd like you to do now is I'd like you to try this example. Go ahead and try to graph this using slope-intercept form or any other way that you can. Pause the video on your own graph paper. Try this one. Okay, so what a lot of you probably noticed was 6x plus 2y equals 12. That's not in slope-intercept form. It doesn't have that same look that we were just practicing of y equals mx plus b. So what you need to do is one of two things. You could either use a table of values like we did in the beginning of the unit. So just make a t-chart, pick some x values, plug them in, see what the y values are that spit out. You'll have a bunch of coordinate points and you could plot them. That could take a lot of time though. Again, so what I want to teach you in this unit, in this objective, is to actually solve this equation for y. So just like we solved the equations previously in the previous units, all you have to do is get y by itself and your equation will look like this, y equals mx plus b. So it's a pretty standard procedure. Whatever number is next to the y, that's going to come last. So because we're going to pick on the lonely number because we want to get y by itself. So you typically subtract everything away or add, depending on what the sign is, everything away from the y. So to do that, we're going to subtract 6x from both sides. My new equation will be 2y equals 12 minus 6x. Now we divide by 2. When I divide one side by 2, the entire other side needs to get divided by 2. So we have y equals 6 minus 3x. So that might not look exactly like slope-intercept form, but using our properties, our addition properties, we can actually change this up if you want to. You don't have to do this, but we can make this look like the typical slope-intercept form. So that minus 3x we can write as negative 3x, and the positive 6 is just a plus 6. And there you go, we have that regular slope-intercept form. You don't have to do this and make it look like this. You can find the slope and y-intercept from this equation if you'd like to. They both mean the same thing. All right, now we just graph like normal. Go ahead, pause the video, graph it. Okay, so we start off at 6. Then from there, we go down 3. When there's no run, put a 1. Down 3, over 1. Down 3, over 1. Down 3, over 1. And this is what our graph should look like. Now, I do want to make a point to show you one thing here that's neat in a way that you can check yourself. So this was the original equation, 6x plus 2y equals 12. I just want to show you that all of the coordinate points on our line should work. So if I choose one of the points on my line, just made a little mistake here. If I choose this point right here, 3, negative 3, that value should work in our equation. So the coordinate point 3, negative 3, which is an x and a y value, should work in my original equation. It should also work in my other equation because I followed the rules of algebra. And that's one of the beauties of algebra. You can make just about any equation look like anything else as long as you follow the properties of equality. So let's just go ahead and show you that this will work. 6 times x will be 6 times 3, plus 2 times y will be 2 times negative 3, and that should equal 12. So 6 times 3 is 18, minus 6 equals 12, and that does check out. The equation does balance. 12 does equal 12, so that coordinate point works in our equation. Okay, here you go. Here's an example for you to try on your own. So go ahead and try to solve this equation for y. You notice that it's a linear equation because it has an x and a y value, and there's no exponents. There's nothing too fancy about it. So just try to get y by itself and put this equation in slope-intercept form so that you can graph it. All right, so the first thing we're going to do is we're going to get rid of that minus 2x because it's kind of lonely, the whole term. So we just add 2x to both sides. And our new equation, 4y equals negative 8 plus 2x. If you had a hard time or you getting that question started, or you did the first part wrong, try to continue on from here. Okay, so now that we have the 4y by itself on one side of the equation, the opposite of 4 times y is divide by 4. What I do to one side, I have to do to the whole entire other side. So my new equation, when we're all done, is going to be y equals negative 8 divided by 4 is negative 2, and 2 divided by 4 as a fraction would just be 1 over 2x. Now, some of you might have been tempted to put that into the calculator and say 2 divided by 4 is 0.5, but you might notice in this next step why that might be difficult to graph after that point. Because when we graph, we want a slope, right? So you just want to simplify that fraction in that step. So here's our equation, and now we're going to graph it. So go ahead, take a second and graph it. All right, so we graph starting at negative 2. Then we're going to go up 1 over 2. In the opposite direction, we'll go down 1, back 2. And there's our line. Okay, one last example. Go ahead, pause the video, and try to graph this situation. Okay, so we see a linear equation. We want to try to put it in slope-intercept form. So I will add the 9x to both sides. And some of you might be a little frustrated at this point because you're noticing something when we do this. So 3y equals 1 plus 9x. And I divide by 3 on both sides. And yes, a lot of you did this right. You didn't do it wrong. You shouldn't be frustrated. 1 over 3 plus 3x is our final equation. And when we go to graph that, let's just copy that up here. Y equals 3x plus 1/3. You might have noticed, 1/3 as a y-intercept is going to be pretty tough to graph. So 1/3 would be right about there. Not an exact value. That's not what we want to see when we graph. We want to see those exact coordinate points. We don't want to estimate because that could lead to error. Now, you could do that, and you could go up 3 from there and over 1, but there are going to be situations that aren't going to be pretty, like this one here. So what I would suggest to do in a problem like this one is to go ahead and use the original equation and make a t-chart. That might be the most beneficial. There are some other methods that we can learn later on down the road, but for right now, if you have an equation, it doesn't look pretty, then you can just use a t-chart and graph it. Okay, here we go. Last example, no tricks this time. Go ahead and solve this one for y, convert it into slope-intercept form, and graph it. All right, so what you should have done is subtracted the 2x from both sides. After you subtracted the 2x from both sides, you're going to divide by 3. Y equals 4 minus 2 over 3x. So negative 2 divided by 3 will give us a negative value, and that'll be negative 2 over 3. Some of you might have put that in a calculator, but remember, when you're graphing, you're going to want a rise and a run. So just simplify any fractions. Don't actually put them into the calculator. So to graph, we start off at our y-intercept, which is 4. Then from there, we're going to go negative 2 over 3. negative 2 over 3. And the opposite direction, instead of going down 2, we'll go up 2. Instead of going right 3, we'll go back 3. So here's our graph. A little crooked, but that's okay. We're just sketching it here. And I want you to take a note of a couple things here. When you look at your equation and you look at your slope, you notice that your slope in your equation is negative 2 over 3, which means that your equation should be going down from left to right. And I also want you to take note that each one of these points that you created will work in both of your equations. It will work in your new equation that you created, and it will also work, they will also work in the old equation, because a line is just a continuous set of solutions for an equation. That's all it is. Okay, just to sum up what we've learned in this quick video, whenever you're given a linear equation, one way to graph that equation is to convert it into slope-intercept form, and then once you have it in slope-intercept form, graph the y-intercept, and then use the slope to plot points from there.